Yeah, welcome everybody. Now let's continue with the questions on vectors. This is another question from May, June 2008. By the way, they are Waec questions. Now, Waec Ssce questions. Number 2, let me call that 2A. The position vectors of points PQ and R are 4i minus 5j, I plus 3j, and minus 5i plus 2j respectively. Now let's sketch that very quickly. Sketching it makes it easier to solve the question. Now this is going to be the origin. The position vector of P, that's OP, is 4i minus 5j. That means it's 4 on the horizontal axis and minus 5 on the vertical axis. So 4i minus 5j is going to be somewhere around here. Let me just put it here. It's a sketch, by the way. So that's 4i minus 5j. So P is 4 minus 5. Now, what's going to be? The next one is Q, which is I plus 3j. That means it's 1 on the horizontal axis and 3 on the vertical. So OQ is going to be somewhere around here. OQ is going to be somewhere around here. So let's call that OQ. So Q will be 1, 3. And the next one, which is OR, is minus 5i plus 2j. Minus 5 is let's put that around here. On the horizontal axis is minus 5, and on the vertical axis it is 2. Let's put that here. So minus 5i plus 2j is going to be somewhere around there. I want to make that a line with an arrow. That this is going to be R minus 5, 2. Now let's read further. Let me erase the markings here. So now let's read further. The position vectors of points PQ and R are 4i minus 5j. We have shown that already. I plus 3j and minus 5i plus 2j respectively. If PQRM is a parallelogram, find question A, the position vector of M. So we want to find the position vector of M. If PQRM is a parallelogram, that means I can sketch a parallelogram here. Let this be the parallelogram with vertices PQRM. Let me call this P, and I know that P is 4 minus 5. Let me call this Q. I know that Q is 1, 3, and this is R, which is minus 5i plus 2j. So I just write it as minus 5, 2. Now this is the M whose position vector we want to find. Let me call that AB. So for now I'm just saying the position vector of M is AI plus BJ. Now how do we do that? I know that for a parallelogram the opposite sides are equal and parallel. So that means this length and this length are equal, and this length and this length are also equal. So QR, the length QR is the same as the length PM. Now we use the idea of the distance between 2 points to find the position vector of M. So that means that's what we do to find A and B. So I know that QR is the same as the square root of minus 5 minus 1 squared plus, let me make that root bigger, minus 5 minus 1 squared plus 2 minus 3, the square of 2 minus 3, and that's going to be equal to the square root of what's PM. PM is going to be A minus 4, the square of A minus 4 plus the square of B minus 5. B minus 5. That's what we have there. Now here we have to be careful. If you do minus 5 minus 1, the square of minus 5 minus 1 plus 2 minus 3, the square of 2 minus 3, as we did here. When you want to find PM, you will not say 4, the square of 4 minus A, and then minus 5 minus B. That will be wrong. If you are saying minus 5 minus 1 the square of minus 5 minus 1 plus the square of 2 minus 3. Then for the second one too, it should be second minus first all squared plus second minus first 2 all squared. That otherwise you'll be wrong. So for this second one, you cannot write the square root of, I think this point has to be made, minus 5, the square root of the square of minus 5 minus 1 plus 2, the square of 2 minus 3 equals, and when you are writing this one, you cannot change it to 4 minus a. You can't change it to the square of 4 minus a plus the square of minus b, minus 5 rather, minus b. No, you can't do that. So if you are saying this minus this squared plus this minus this squared, you are finding the whole of the square root of that to find the length QR. Then you should do the same for PM. PM too will be a minus 4 and not 4 minus a, because here you said minus 5 minus 1 and not 1 minus 5. So you have to be very, very careful, otherwise you'll be wrong and you'll be wondering where you made the mistake. So that means length PM, back to the solution now, length QR is the square root of minus 5 minus 1 all squared plus 2 minus 3 all squared, and it's the same as the length PM, which is a minus 4 all squared plus b minus minus 5 all squared. So this is just the same as writing square root of minus 5 minus 1 all squared plus 2 minus 3 all squared equals square root of, that's going to be a minus 4 all squared plus, now it's going to become b, minus times minus is plus, so that's b plus 5 all squared. Now we can compare the left and right hand side. First of all, if I square both sides, I'm going to have minus 5 minus 1 squared plus 2 minus 3 squared equals a minus 4, the square of a minus 4 plus the square of b plus 5. That's what happens when you square both sides. So now what it means is a minus 4 is the same as minus 5 minus 1. A minus 4 is minus 5 minus 1. And I can write that a minus 4 equals minus 5 minus 1. A minus 4 is equivalent to minus 5 minus 1. And that means a equals minus 5 minus 1 is minus 6. And when minus 4 goes to the right hand side, it becomes plus 4. So a, that means a equals minus 6 plus 4, which means a equals minus 2. And in the same vein, b plus 5 is equivalent to 2 minus 3. So that means b plus 5 equals 2 minus 3, which means b equals 2 minus 3 is minus 1, and when plus 5 goes to the right hand side, becomes minus 5. So b equals minus 6. Now that therefore means that MAB is the same as M. What is A? A is minus 2 and B is minus 6. How about correct? A is minus 2 and B is, yeah, that's correct, B is minus 6. So MAB is the same as minus 2 minus 6. Now that therefore the position vector of M, which is OM, is equal to minus 2i minus 6j. That's the position vector of M. Now to the second question, which is B. Question B says find the magnitudes of the vectors PM and PQ. Okay, to do that, let me bring back the diagram. Magnitude of the vectors PM and PQ. PM and PQ. Okay, let's see magnitudes of the vectors PM and PQ. I think I would like to use this diagram to do that. It's easier when you have this kind of diagram. Sketch a diagram like this. Now let's put it here. This shows all the vectors. Now the one we need to add is PM. The one we need to add is OM. OM is minus 2i minus 6j. So minus 2 is going to be somewhere around here, and minus 6 can be somewhere around here. Minus 6 can be somewhere around here. So the vector OM is going to be this. Let me draw that again. The vector OM is going to be, I want that to be the vector OM. This is the vector OM. That's the vector OM. M, which is minus 2 minus 6. That's the vector OM. Now, so what do we want? This is the origin O. Now we want to find the magnitudes of the vectors PM and PQ. Now how do you find the magnitude of PM? This is PM. This vector is PM. This is PM. That's the vector PM. So, and it is the same as PM is the same as PO plus OM. PM equals PO plus OM. We need to find the vector PM before we can find its magnitude. PO is the same as, vector PO is the same as minus OP plus OM. So PM is the same as PO plus OM, which is minus OP plus OM, and that's equal to minus into the vector OP is 4i minus 5j plus OM, which is minus 2i minus 6j, and that's equal to minus 4i plus 5j minus 2i minus 6j. So that means the vector PM is equal to minus 4i minus 2i is minus 6i, 5j minus 6j is minus j. That's minus j. So vector PM is minus 6i minus j. Now its magnitude is therefore the magnitude of the vector PM will now be square root of the square of minus 6 plus the square of minus 1, which is the same as the square root of 36 plus 1, which is root 37 units. That's the magnitude of the vector PM. Now we need to find the magnitude of the vector PQ. First of all, we want to find PQ before finding its magnitude. This is the vector PQ. This is the vector PQ from P to Q that way. Now PQ is the same as PO plus OQ. The vector PQ. We want to find the vector before we find its magnitude. Is PO plus OQ, and that's the same as minus OP plus OQ, which is equal to minus into bracket 4i minus 5j. I hope that's correct. That's correct. And OQ is I plus 3j plus I plus 3j, and that's the same as minus 4i plus 5j plus I plus 3j. So that means vector PQ is equal to minus 4i plus I is minus 3i, and 5j plus 3j is 8j. That's 8j. So that's the vector PQ, and its magnitude therefore is going to be the square root of the square of minus 3 plus the square of 8, and that's the same as the square root of 9 plus 64, which is the square root of 73. That's the square root of root 73 units, and that's the magnitude of PQ. Now what's the next question? The next question is C, and it says the acute angle between PM and PQ. Okay, the acute angle between PM and PQ, let that angle be cos theta. The dot product of PM and PQ is equal to the product of the magnitudes of PM and PQ multiplied by the cosine of that angle between them, and the angle is theta. So PM dot PQ is the same as the product of PM and PQ multiplied by the cosine of the angle between them. The angle between them is theta. So now this simply means, so let's find PM dot PQ. PM dot PQ is the same as, what's the vector PM? Vector PM is minus 6i minus j. So that means minus 6i minus j dot, what is the vector PQ? Vector PQ is minus 3i plus 8j. Minus 3i plus 8j. So that dot product is going to be minus 6 times minus 3 plus minus 1 times 8, and that is same as that's 18 minus 8, which is 10. Now, so that simply means and we know that from here we can find cos theta. Cos theta is going to be, cos theta is the dot product of PM and PQ divided by the product of the magnitudes of PM and PQ, and PQ, and that simply means we found the product of the magnitudes of PM and PQ, that's 10. So that means 10, that's PM, that's 10 over the magnitude of PM is, what's the magnitude of PM? That's root 37. So 10 divided by the square root of 37 multiplied by the magnitude of PQ, which is root 73. That's it, root 73. Of course, this is PQ, and that simply means, let's do that first of all. 10 divided by that's the same as root 37. That this is simply the same as 10 divided by the square root of 2701. 2701. So 10 divided by the square root of 2701 is going to be 0.1924. That's cos theta, and that therefore means theta itself is a cos inverse of 0.1924. So let's find the cos inverse of our answer, and that's 78.906. But they said we should find correct to one decimal place the angle between PM and PQ, and that's 78.9 degrees to one decimal place. So the angle between PM and PQ is therefore 78.9 degrees. Now question D, what does D say? The area of PQRM. How do we find the area of PQRM? How do we find the area of PQRM? Okay, let me bring back the parallelogram just to see clearly what the area should be. This is the parallelogram PQRM, and I can paste that here. Let me paste that here neatly. That's parallelogram PQRM. Now we already know the angle between, I can take all of this out. We already know the angle between PQ and PM, and that angle is 78.9 degrees. 78.9 degrees. So to find the area of parallelogram PQRM, the area of parallelogram PQRM, we just use the and that's just going to be area, that's just going to be PQ times PM sine 78.9 degrees. When the angle between the adjacent sides of a parallelogram are given, the area of parallelogram is given by the formula AB sine theta. So area of PQRM is equal to PQ times PM sine, not cos, sine 78.9 degrees. That angle is the angle between PQ and PM. So, and that simply means the magnitude of PQ is root 73 times magnitude of PM is root 37. Let's check that to be sure. Magnitude of PQ is root 73. Yes, that's correct. Magnitude of PM is root 37. That's correct. So that means root 73 times root 37 multiplied by the sine of angle 78.9 degrees, and that's the same as root 33 times root 73 times root 37 is root 2001. That's equal to, root 2701 times sine, or you can find that first of all, that's equal to 2701 now times multiplied by the sine of 78.9 degrees, and that's 50.999 50.999 999 yeah 999. Did they say we should approximate? They just said the area. Okay, and that's approximately 51 square units. Areas are usually in square units. That's 51 square units, and that's it. Very, very simply. All right, so can we go to the next, or take a breather and then come back? Yeah, let's take a breather and come back to the rest. Thank you very much, and I'll see you in the next. Bye bye.